There is a bean that produces more protein per square meter than raising cattle. It doesn't need soil, fertilizer, or sunlight. It grows to harvest in 5 days on your windowsill. NASA has been studying it for space stations. The United Nations named it the most promising food crop of the 20th century. Then he virtually disappeared from Western consciousness. One window box can produce fresh protein all year round. By the end of this video, you will know exactly how to do it. Sometimes the most valuable things are not hidden in the laboratory but grow next to the road. But first, try a simple experiment at any supermarket this week. Before we get into the how-to guide, tell me something. Have you seen this plant growing wild near where you live? Leave it in the comments. Ethnobiological research shows that many nutrient-rich plants grow undetected in urban environments, creating a chasm of curiosity about hidden abundance. Sometimes the most valuable things are not in the laboratory, but next to the road, climbing a fence, or growing in someone's garden. Now try a simple experiment. Walk into any supermarket this week and spend 1 minute in the meat section. Watch the people standing at the counter. You'll see the same pattern over and over again. They take packages of ground beef, look at the price, and put it back. According to the USDA, beef prices rose between 2020 and 2024, confirming emotional observations with measurable economic reality. It's not just the price, it's the facial expression and mental arithmetic in the aisle. Protein has become expensive. But on a windowsill, 3 blocks from the same supermarket, someone is producing protein without land, without animals, without refrigeration, and without a supply chain. Just a shallow tray and tap water. The plant responsible for this has a detail that sounds almost fictional. Its pods have 4 longitudinal wings. That's why botanists named it Sophocarpus tetragonalibus, the winged bean. In the Philippines, many farmers know it by its local names, which vary from province to province. In Indonesia and throughout Asia, it appears in markets under other generic names. In Papua New Guinea, where it has been grown for more than 2,000 years, it has dozens of names. Archaeological finds in Papua New Guinea date cultivation back to at least 2,000 years ago, supported by regional agricultural research. Each name represents generations of cooking, soil, climate, and survival. The West almost forgot him, but science did not completely forget him. In 1975, the National Academy of Sciences assembled a group of agricultural scientists in Washington. Their mission was simple: identify underutilized tropical plants with exceptional potential. They reviewed hundreds of candidates and selected the winged bean for special consideration. The report that emerged from this work, published in 1981, used unusually colorful language for a scientific document. They called it a supermarket on a stalk. This phrase remained for a reason, because almost every part of this plant is edible. Young pods taste similar to green beans. Mature seeds contain protein levels that rival soybeans. The leaves provide nutrition comparable to spinach. Flowers can also be eaten by creating a vivid mental image of a single plant producing pods, leaves, flowers, and tubers at the same time. What almost no one in the West sees is that underground tubers, that hidden part under the soil, can be up to 20% protein. In comparison, potatoes typically contain about 5%. This means that for the same harvest weight, a winged bean tuber can provide 4 times more protein than a regular tuber. But the real story is in the seed. Laboratory analyses published in food science journals have measured the winged bean's protein content to be between 29 and 42%, depending on the variety. Beef by dry weight is usually about 26%. The fact that a plant seed could rival animal muscle tissue in protein density was supposed to be revolutionary, and yet this did not happen. Why? Because there is another feature that makes it even more destructive to the industrial system. It is a legume plant that fixes nitrogen. It forms nodules in its roots with rhizobium bacteria, which convert nitrogen from the air into food for the plant. In practice, the winged bean fertilizes itself. Agronomic research supports reduced fertilizer dependence, adding scientific depth. Less dependence on synthetic fertilizers, less dependence on the industrial chain, fewer repeat purchases. This is not the kind of culture that anyone is trying to sell you. In the 1980s, agricultural research stations in tropical regions launched serious programs. Research centers in Asia have developed improved varieties. Stations in Nigeria and India, including a collaboration between IITA and IRRI, tested cultivation methods, anchoring the narrative in real-life programming. Agricultural organizations have promoted the winged bean as a candidate for bolstering protein intake in diets where meat is expensive or unavailable. For a moment, it looked like the winged bean was going to transform global protein production. Then interest faded. Funding changed, programs were closed, research moved to other projects. The winged bean has returned to its traditional zones, where it never disappeared. In Southeast Asia, it continued to be grown as always, in backyards, gardens, and local markets. But the promised revolution never took root in the fields of Europe or North America. The reason for this has more to do with economics than biology. In tropical climates, the winged bean can behave as a perennial plant. You plant it once and it comes back year after year, producing some of its own fertility. Each of these qualities makes it valuable for food security and, at the same time, makes it unattractive to an agricultural system built on constant sales of seeds, fertilizers, and chemicals. The Green Revolution focused on staple crops, creating a broader historical context to explain systemic neglect. But here's the part that almost no one explained to you. You don't need a tropical farm to access the best part of this bean. You don't need soil, you don't need field. And in fact, for the most efficient version of the home, you don't even need direct sunlight. You only need to understand germination. Because the secret is not only in the plant, but also in what happens when the seed wakes up. When a seed germinates, its chemical composition changes. Enzymes that were inactive become active. Starches are converted into simple sugars. Proteins become more digestible. Vitamins are synthesized from precursors. The seed ceases to be a storage unit and becomes a living system designed to grow. Research published in food chemistry journals has documented these transformations in measurable terms. For example, trypsin inhibitors, compounds that interfere with protein digestion, can be dramatically reduced during germination, sometimes between 60 and 80% depending on the protocol and timing. This defense is useful when the seed is dormant and trying to survive. But once it germinates, growth becomes a priority, and that chemical armor is switched off. Vitamin C tells an even more surprising story. Dry seeds contain little vitamin C, but after a few days of germination, the content can increase dramatically. In winged bean sprouts, the increase to the 5th day can be dramatic under certain conditions. The seed produces this vitamin in preparation for an active life, and you harvest this nutritional boost at exactly the right moment. Protein digestibility is also improved from approximately 65% in raw seeds to over 85% in sprouts. This means you're not just eating the protein on paper, your body is absorbing more of what's there. In practice, sprouting does some of the digestive work for you. Here is the critical window, the point of maximum density between the 4th and 5th day. At this point, the cotyledons, the first two structures that emerge from the seed, have already expanded. They still concentrate the original nutrition of the grain, but now with the enzymatic improvements created by sprouting. Not much energy has yet been directed towards long stems and large roots. Days 4 through 5 are usually the harvest point with the best texture and best value per volume. Now yes, here is a 5-minute method that works in any kitchen. First, get the seeds. In Asian stores in many cities, the winged bean is sold dry, sometimes under names like Goan bean or angular bean. There are also online sellers and seed exchange networks offering unprocessed seeds specifically for germination. 1 kilogram usually costs very little compared to animal protein and produces dozens of harvests. You're not buying food for one day, you're buying cycles. Second, do a quick inspection. Look for seeds and remove any that are cracked, very dark, visibly moldy or damaged. Damaged seeds are an entry point for fungi. This step takes 30 seconds and can save you a week of failed batches. Third, soak them. Place the seeds in a glass jar or bowl and cover them with room temperature water. Use about 3 times the volume of water because the seeds will absorb water and expand. If some seeds remain only half hydrated, they will germinate unevenly. Let them soak for 12 to 24 hours. This range matters. Less time may result in poor germination. More time may invite bacterial growth. Fourth, drain the water completely, rinse with fresh water, and drain again. The golden rule is simple. Never leave standing water. Fifth, use a container with drainage. This can be a commercial sprouting tray, a window box with holes, a cloth-lined colander, or a perforated tray. The container is less important than drainage. Standing water is an ideal environment for mold. Sixth, position it correctly. Place the container out of direct sunlight. The sprouts develop better in indirect light or even shade. Direct sun heats the seed mass, speeds up bacterial growth, and can create a bitter taste. A countertop away from a window works well, and a cabinet with the door partially open also works. Seventh, rinse twice a day, morning and evening. Use water at room temperature. Shake gently to wet all seeds. Drain thoroughly. Each flush removes metabolic waste and adds oxygen. Skipping washes is the fastest way to end up with a batch that smells funny. Eighth, temperature. Germination changes dramatically with climate. Between 20 and 30 degrees Celsius is usually ideal. Below this, growth slows down. Above this, pollution increases. Most homes fall into this range at some point during the day. If your kitchen gets very hot in the summer, find a cooler place. If things are cold in winter, avoid icy windows and find a soft corner. Now pay attention to the process markers because they give you control. Day 2, you will see the tips of the roots coming out of the seed. Day 3, the roots elongate and the cotyledons begin to separate. Day 4, the cotyledons expand and become pale greenish or yellowish in color. Day 5, maximum expansion before the stem begins to elongate and release energy. Harvest by cutting off the sprouts at the base or lifting the entire mass if you sprouted them in a tray. Rinse the crop and drain well. Store it in the refrigerator in a container with a paper towel to absorb excess moisture. When stored properly, they stay fresh for 5 to 7 days, but the best flavor and texture is usually within 48 hours. Here's the trick that turns this into continuous production. Start your next batch the same day you harvest. With 2 containers in rotation, you have fresh protein constantly. 5 minutes a day, without seasons, without climate dependence, and without waiting for the price of meat to fall. Now let's do the math, because here opinion becomes a system. A standard 12-inch window box can produce in a 5-day cycle a volume of sprouts that, on a dry matter equivalent basis, can reach approximately 100 grams under reasonable conditions. If we assume an approximate protein content of 35%, that's 35 grams of protein per cycle. 6 cycles per month, more than 200 grams. Over a year, more than 2 kilograms of protein coming from one window. Compare this to meat. Getting 2 kilograms of protein from beef means raising the animal for 18 to 24 months. This animal consumes tons of food, much of it grain that humans would eat. FAO reports on feed conversion ratios show that beef production requires up to 15,000 liters of water per kilogram. Requires water, land, veterinary care, transport, slaughter, infrastructure, refrigeration, and distribution. Your box requires tap water, a container, and minimal discipline. The contrast is not only logistical, but also structural. Meat depends on systems that break down easily. Fuel prices, refrigeration, transportation, feed prices, and availability. Home sprouting depends on something that rarely disappears even in times of crisis: water and time. If you have seeds, you have a protein bank. If you have a container, you have a factory. Not an industrial factory, a biological factory. This is food sovereignty, not silos, not piles of ultra-processed food. Sovereignty means the ability to produce basic nutrition in your own space through a simple and repeatable skill. Urban agriculture in Cuba in the 1990s provides historical evidence of how societies adapt to food insecurity through decentralized production. This is why the winged bean is such a powerful symbol of an inconvenient truth. Real proven solutions don't become mainstream if they don't fit into the supply chain profit structure. The winged bean waited while the West ignored him. He waited while money chased patentable products. He waited while huge markets were built for isolated nutrients in capsules. He waited while prices rose and families made calculations in the meat aisle. Seeds don't understand markets. They understand water, temperature, and time. Give them these three inputs, and they transform from dormant storage to living nourishment, from forgotten culture to kitchen staple, from agricultural scarcity to food security you control. Ancient traditions of seed saving contrast with modern supply chains, deepening the thematic resonance between independence and systemic dependence. Each seed contains not only the future plant, but also freedom from external distribution systems. When you sprout seeds on your windowsill, you are recreating a process that is thousands of years old. The Han Dynasty in China documented germination techniques, linking modern science with historical continuity. If this video helped you, do one quick thing. Subscribe to the Botanical Repository. If you start your first batch today, please come back and comment on what day you harvested and how the flavor turned out. Knowledge becomes real when it moves from the screen to your kitchen. Try a 5-day experiment. Start one batch of winged bean sprouts and document the process. Now you know. What happens next depends on the box in your window and 5 minutes of your attention every day.